In the change problem, we use the recursive technique, and in this technique we do not consider the combination of coins, but we are concerned with the minimum number of coins. And in this technique, I already told you, we consider the computation of the calculation of coins time and again, and we do the recomputation of the problems which we compute already. So we are concerned with the total number of minimum number of coins rather than the combination of coins. Here we can see is the recursive change algorithm, and here we mark them as M as the change, C is the types of the coins, and D is the denomination. So the first step will be the if condition, and if is M is equal to 0, if there is no change to return, then we will get the answer 0. So the best number of coins, third step, best number of coins we determine as infinity. And in the fourth step, for loop will apply, and we will assign the value of 1 to D to I. So it means that the value will start from 1 and it will go up to the value of D, means the maximum number of coins. So fifth step will be the if loop will apply, and we consider that if M, the change we want to return, is less than or equal to C1, the first coin, and if it is less than C1, then what we will get is number of coins, and we will assign it the value MCICD. So this step is a recursive call. So it will call again and again, and this step will take a lot of time to compute the number of coins. So the recursive change will call this D, and if it will calculate the number of coins, because we have already seen M minus C1 means, for example, if M is 77, we have the minimum number of value of coin is 1, and if we'll minus 76, and we get 1 coin of 1 cent. So it means that the minimum number of coins plus 1. So plus 1 is this plus 1. So if number of coins plus this coin is less than best number of coins here, if it is less than, then we will assign this value to the best number of coins, and that will be number of coins plus 1. This is the value. So if it minimum number of coins, then we will return the answer as best number of coins. So here we can see that this is a recursive algorithm, and the step number 6 will call the recursive for D again and again. And we can see here the sequence of calls that we have seen in the step number 6. The recursive change has a feature in common with the sequence of calls made in the recursive Fibonacci. We have already seen previously that the recursive Fibonacci problem, we have solved it by using this recursive calls. The recursive change recalculates the optimum coin combination. So this is the problem with the recursive algorithm. So it recalculates again and again for the optimum number of coins for a given amount of money. And for example, we will see in the next slide that the optimum number of combination for 70 cents is recomputed again and again repeatedly 9 times over and over as stated. So we will see the example here. So this is the example. So we can see here that we have the 77 M. We have to return back the change of 77 cents, and we have to return 70 cents, and we have the cents value of 1 cent, 3 cents and 7 cents. So we have these 3 coins of value 1, 3 and 7 cents. So we can see here, to calculate the value of 70 cents, we have different combinations, and the total number of combinations we can see here. First is only 1. If we minus the value of 7 cents from here, we get 70. So this is the only one number. So again we can see we have the 3 combinations of different cents. If we minus 77 from 3, 3 and 1, again we can see 3 and 3 6 and 1 7. The answer will be 70. And the next combination will be 77 minus 3 plus 1 4 and 3 7. Again it is 70. So we can calculate it all will be 70. And we have this type of combination. We have 3 combinations of this one, and we have 5 cents, 2 3 4 5. We have combination of 5 combinations, and lastly we have 7 1 cent, and it is only 1. So we have total of 10 different combinations by using the cents of the value 1 3 and 7, and we get the total of 10 combinations. So we can see here that we have to calculate the different types of combination again and again, and this is the recursive call for this algorithm. And if we want to calculate the coin combination for 20 cents, and we have to calculate the billions of time, and this is really impractical solution by using this recursive change algorithm. So this is the drawback of this algorithm, that it computes the value again and again. So here we have 10 combinations. We see 1 3 5 and 1 again. So we can draw it in a flow sheet diagram, and we can see here in the next slide. So we can see 77 cents, and we have 3 options. We minus 1 cent and we get 76. Again, if we minus the 3 cent, we get 74, and similarly 7 we get 70. So this is our target, 70 cents. So if we minus the 7 cents, we get this 70. So again we will consider this one and minus 1 3 and 7 from this, and we will get 75 73 and 69. Similarly we minus 74 from minus 1 3 and 7 from this one. Again we minus 1 3 and 7, we get the answer. So again we will use this 75, and we minus 1 cent 3 cent and 7 cent, and we get it 74 72 and 68. So here if we minus 1 3 and 7, but when we minus 73 minus 3, we will get 70. So again our target, this one is 70. Similarly, if we minus 1 3 and 7 from here, from 1 we get the 70. Similarly from here, if we minus 1 3 and 7 from 3, we get 70. So we get 370 here. 1 is here, 2nd is here, 3rd is here. So we can calculate it, that 77 minus 1 minus 3 and again minus 3. So we get the same answer, 77 minus 3 minus 1 minus 3. So if we go back and we see, we can see here that we have the same answer here. If we minus 3 3 and 1, so we have seen that we draw the tree and we have the same answer, 3 3 1, and in the other one we will 3 1 3 and 1 3 3. And if we continue it, we will again get this one, this one, this one, and further we continue, we will get this answer.